Hey guys, so it's been quite a while. Apologies for the change in setting. I've actually moved some stuff around and I tried to get this as my main workbench and it's proving quite decent. The old set is right to my left and yeah, I've been doing most of my stuff here because the 3458A and some of the other gear that I had lying around here has moved to, well, the topic of a different future video. And I've relegated just the bare minimum equipment to this desk. So I have the oscilloscope, I have the electrometer, power supply, etc. On that side, I have another computer there. And yeah, long time no speaky. It's been quite an interesting few weeks, so I've taken some days off of work and I'm enjoying some late mornings with plenty of coffee and good food and just getting into the holiday spirit. But I still have to do my, you know, electronics stuff so I don't go completely nuts and bonkers. So for all of those who are watching and have a hard time around Christmas, I'm one of you guys. I never liked the holidays. I don't really feel comfortable around the holidays, and I have formed some very unhealthy associations with the idea of holidays. So don't worry, it's gonna pass. Most people are depressed around the holiday season, and it's something normal. And tomorrow is gonna be a new day, and we'll all be there. So, what have I been up to? Well, I think you saw and heard that I got a 3458A finally. I actually got a second 8.5 digit multimeter because I'm crazy. I got a Solartron 7081, which will be discussed in the next video because it was broken. Quite an interesting failure mode, and it took me a few days to troubleshoot and repair. And now it's working, and it's actually measuring my 731B. You won't see it in this video. I'll do a video about it before I send it off to its new home. A friend and I are trying to set up a European database of voltage references and stuff and try and get some values and known references traded and communicated between ourselves. And so yeah, that's going to a better cause because I don't need to have two 8.5 digit meters. And I have some more equipment that I'm going to show very soon, but for the moment I've been in contact with a surplus electronics reseller and I managed to get quite a lot of stuff. I don't know if I've got enough time in this video because there's way too much stuff to cover. So there's gonna be at least another video the next day after you see this one, maybe even the same day if I'm lucky, concerning one of the items. But let's start a bit slower. So I got some very interesting vacuum tubes because we all love vacuum tubes, right? And let's start off small. So I think you remember I showed that I got those 2 bags of vacuum tubes. This wasn't in that lot, but I actually have around 10 of these right now. These are high voltage rectifiers, so they're 150 milliamps, 55 kilovolt rectifiers. They have a glorious shape to them, ceramic base. And I think in operation these actually give off X-rays. So needless to say, I'm not going to power one up. I don't have a heater supply strong enough for these anyway, but I don't have a 55 kilovolt supply either, so, but they're very, very pretty. They're just a diode, directly heated cathode. Very interesting that the filament and the cathode aren't exactly the same thing, but they're electrically connected. So two of the pins are the heater, two of the pins are the cathode, and they're tied together at the midpoint of the cathode, so of the heater. So you can sort of see in there's a coil. It's deformed by the glass, but you can sort of see a coil in there, and that's the heater. And the plate with the fins on it, looking kind of like a rocket, is a Kerbal Space Program rocket, actually, is the anode. So I got about a dozen of these and about a dozen of the smaller ones, and they're very pretty. I really like the look of them. And let's talk about oscilloscope tubes. So I have a teeny tiny one we'll take a look at first. So this is a Philips 391 DH, and it's made, I think, in about 1964. It's got its base, and basically there's a focus control here, and there were a couple of connections going to the high voltage, the filaments are these two pins. I'm going to try and power this one up, or at least insert a picture of it lit up. You can see there's a bit of burn-in of the phosphorus where the screen was active most of the time. And this one is really cute. I actually have two of them. This one, sadly, as you can see, the getter is completely vanished, so this one's got air inside it now. And I think this was off of some sort of RF equipment, probably a modulation oscilloscope, something like that, built into some piece of RF equipment. And then I have this monster. Oh, it fits in the frame. That's brilliant. So I have this monster. It's a dual beam, so it's got two electron guns. A dual beam Soviet 13 LO48N, I think. It's made in the 5th month of 1979, and it's giant, absolutely giant. Sadly, I don't think I have high voltage enough to get this one working. I tried. I found the pinouts for the base. It's got a boatload of pins on the base, and you can see the two individual electron guns pointing a bit towards each other. So we have a heated cathode, a couple of focusing and modulator grids, and then we have the deflection plates, vertical and horizontal, for twice the scope, basically. So you can have a dual beam scope that can have chopped traces on both of them, so you can have a 4-channel oscilloscope. And if you have two time bases, you can look at a 1 Hz signal on one trace and 1 megahertz signal on another. So that's very, very cool. So this is again a 13 LO48, and I think 13 refers to the diameter of the screen size, basically. So more or less, I think it's the maximum diameter of the tube, so it's 13 centimeters across. Giant. Okay, keeping in the same theme of displays, we have one of these beauties, and this is a radar tube. As you can see, the burden is mostly in the center, where basically the beam spent most of the time, and this is a 13LM31B. So the difference between LO and LM is that LO tubes are electrostatically deflected and LM tubes are electromagnetically deflected. So this needs a yoke around the neck of the tube to deflect the beam and to scan it across the surface of the phosphorus. And this is a very long persistence phosphorus. It's blue, and the decay for it is orange, which is very, very interesting. We have the anode cup here and a standard 8-pin base, out of which we only have the heater, the cathode, and a focusing and modulator grid. So that's everything in here. And this is very pretty. I'm gonna try and power it up. I need to find a suitable yoke for it, and then I'll try and make a couple of dancing figures. I think if I can just get a yoke off of a color TV screen or something like that and feed some signals into it through a power amplifier or something, I could get the beam to dance across a bit. So that's about it for this one. Very pretty. Same screen size as the big monster, but because it only needs one electron gun, it's nowhere near as complex. It doesn't have deflection, electrostatic deflection. It fits in a much smaller envelope, but you can see that the screen sizes are basically the same. And the color of the phosphorus indicates that this is a longer persistence phosphorus, as you would need in a radar. And we have yet another one of these bad boys. This is the first actual oscilloscope tube that I've seen that had copper structures inside. I'm not even sure if they're copper, and why I'm saying that they might not be copper is that copper outgasses insanely in vacuum. So copper is very, very bad of a vacuum material. And yeah, I think this is a pretty high speed oscilloscope tube. I think it's made for pretty high frequencies. And yeah, I couldn't really be bothered to find any information about it. I think it's German, made in a GDR, and yeah, the getter is still fine on this one. You can see it has a couple of getter spots, and we have X and Y, and this is the anode, and we have the filament and several grids in here. So this is all the electrostatic lensing and optics, basically, that forms a nice crisp small beam to project on the front of the phosphorus. And this is a very, very low persistence phosphorus screen. And yeah, let's look at something that, apologies, you'll see what made that noise in a minute. And you'll see why it made that noise. But let's look at another couple of very interesting tubes. So I have these two bad boys. And care to wager a guess what this might be? So these two are electrostatic storage tubes, if I'm not mistaken. So these also require yokes. And what's going on, and it's kind of easier to see in this one, is that you have a very, very thin mesh floating over this anode thingy. And you can scan a beam of electrons over that mesh and charge specific portions of it with electricity, and store some charges on the surface, and then you can read those charges out. So this is like a memory storage tube, and this one is read a bit differently. It has a collector thing here that would go to I think a transimpedance amplifier or a charge amplifier or something like that. And yeah, this was actually used in cooperation with the radar tube. So these are all radar equipment. I haven't got much info on these because the part numbers off of them are kind of cleanly rubbed off. This one still has something written on it, but it hasn't led to any results. Maybe some of you guys know knows something more about these. And last but not least, this is a big boy. This is a GU10A transmitter triode, and again copper insides. This is not uranium glass, it's just painted glass, and this has got to be like the biggest tube I've ever touched. Like a GU81 is just child's play in comparison to this thing. This thing has a 7-volt heater, these two pins here, that consumes 70 amps. So it's almost 500 watts just for the heater. It can withstand about 3 to 5 kilovolts. It can run up to 60 megahertz, if I'm not mistaken. And it can pull like a full amp through it. And it can dissipate, I think 10 kilowatts of power. So I'm pretty sure that 1 amp isn't really I didn't read the specifications correctly. I think that 1 amp is something, but I don't know. So 3 kilovolts to get 10 kilowatts of power dissipated in this. It would have a very tight-fitting collet closing chuck sort of thing against this anode, which would actually act as the heat sink, and the filament is running all the way up through here with the cathode. And this is the grid, and the grid is connected to this bit here. So dissipating 10 kilowatts, it would need to have at least like 3 amps at that voltage. So I don't know, I might have read the specifications wrong on this thing. I don't speak Russian, but Jesus, look at that. This is so pretty. And I have ordered the cheapest transformer welder that I could find, just in order to power this thing up. So if it needs 70 amps, I'm just gonna set the thing to 70 amps, and we'll take a look measuring the voltage and the current through the heater, because I have one of those clamp meter things, and we can just stick a couple of voltage probes on the thing while the transformer is humming its ass off, trying to supply 70 amps through this thing. It's just insane, and it weighs a ton. Like, it weighs, I think, a couple of kilos, 2 or 3 kilos, something like that, 7 pounds. Giant. And this was new in box. The sponge inside was completely decomposed, and I had to wash it off with IPA, and where the sponge was touching the copper, it kind of pitted the surface. So I don't think this is actually usable anymore as intended originally, but you can see, so here there was no sponge and it didn't touch it, so it didn't pit it. But yeah, this would be a very, very cool nightlight, though 500 watts for a nightlight, more like a 500 watt heater. So yeah, right. Okay, so this is about it for the tube section of the video, but don't worry, it's not over yet. I don't know if you're worried or not about that, but you know, I like to hear myself self-talking. Oh, no. I have one more tube to show you guys, and you won't believe it's a tube, but trust me, it is a tube. So wait for it. It's heavy. How do you like them apples? So this says input, and this says output. Выход. UV100A. UV, if you remember my traveling wave tube, that was also marked UV, so that gives us kind of an indication of what this might be. And it says внимание. Don't bring anything closer to 400 millimeters to the magnet, or 250 millimeters. So 400 millimeters to the core and 250 millimeters from the magnet. So I'm not wearing my watch because it would totally magnetize the hell out of my watch, and you can see why. So there's a giant magnet in here. So, and the poles are, you can pretty much tell where the poles are. They're on either side. And they're held together with these screws, but we can take a sneak peek inside by taking off these screws. And while we take off these screws, I can explain what this thing is. And for those of you who haven't picked out yet, yes, this is a magnetron. It's the second largest that I've seen in real life. And it's the largest magnetron that I've ever owned. So microwave oven magnetrons are, I think, more powerful than this is. I'm not entirely sure. I didn't find any data on this unit, but I'm pretty sure that this is much higher frequency, and the quality of the output signal has, like, its order of magnitude is better. So this is the output. This is collecting the output and it's snaking its way back through here. There's some wires here that they either power the heater, or the thing on the back was the heater, and these are the anode supply or whatever. Actually, I think the anode is the output, so don't quote me on that. I'm not sure. No, it's not the output. Anyway, thoriated tungsten filament inside. Magnet makes the electrons spin round, baby, right round. And there's some cavities inside that kind of do the same thing as you do with the air blowing over a bottle. So the sound, or whistling, or a flute. And a good comparison, like comparing this to a microwave oven magnetron, is like comparing somebody blowing over a glass bottle versus somebody blowing into a flute, actually over a flute. So the signal that this thing puts out might be slightly less powerful than the one put out by a microwave oven magnetron, but it's far cleaner. And yeah, big boy. And you can see those weird military connectors, and I find it very fascinating. So if I turn on the scope, and you'll excuse me for moving the image a bit like this, you can see that the scope image is completely wonky, and it's influencing it from a very far away. So now it's pretty much fine, and if I bring it anywhere near close, it makes it cattywampus. So quick apology while I screw this thing back together, because these are stainless steel screws, and I've never seen stainless steel screws on anything Soviet. So you can imagine how important the magnetic field in this thing is. And I think they used stainless steel or copper screwdrivers and tools to assemble these things, because it's taking all my brain power to screw these things in without, losing the screws everywhere. So it's very strong. Heh. Grog like big magnet. Alright, let me just put this thing to the side. And let me carefully move you back. And what should we talk about next? Oh, I know. Oven-controlled crystal oscillators. And we have a Czechoslovakian one and two Soviet ones. And we're gonna tear into these one by one. Sadly, this one was actually working, and I left it overnight to run and stabilize and see if I can measure the frequency with any remote form of accuracy, but something happened to it and I'll tell you all about it. And this one is just it's not an oscillator, I think, it's just the quartz and the heating mantle for it. This one is a full-blown oscillator, so let's start in increasing order of size with this cutie. And you can see that it's got a blankie, a couple of blankies actually, and it's very well insulated. And let me zoom in actually. Oh, perfect. And it's got this weird spongy material which is completely decayed and solidified over the years. Oops. Let me get a screwdriver and try and take this apart for you guys. So, quick comparison. The LTZ-1000, world's best voltage reference, is in a very good case a couple of ppms per year of drift, and a couple of parts per million per degree centigrade. People have gotten it better than that, but this is 0.1 parts per billion per Celsius. So time nuts have it so much easier than volt nuts. This is a excellent quality frequency standard, but frequency standards are much better than this. So this equivalent in new parts would be about $100, and something as good in the voltage domain does not exist. The only thing that's close to very good voltage standards, which is the only voltage standard that gets close to frequency standards is the Josephson junction, which itself is based on a frequency standard. So yeah, time nuts have it so much better. They have the cesium beam clocks and atomic clocks and rubidium frequency standards and all sorts of stuff like that. So there's 3 screws on the bottom that we can undo to expose the bottom side of the circuit board, and there's an operational amplifier and a couple of transistors in there to stabilize the temperature in the crystal itself, around the crystal itself, and you'll see that it's doubly insulated, and you'll see that right away. And the Tesla part, you can see there is a 723, which is an adjustable voltage regulator with adjustable current limiting. And let me show you what failed on this thing. So you can see the spring here. So this spring was meant to be soldered with that specific kind of solder, which is a very low melting temperature solder. And this is sort of an over temperature protection. So if the thing fails, this basically trips and disables the heaters, and this is what happened to this device, and I have no idea why. And we have some, I think they're probably resistance networks, and there's a transistor mounted with heat compound, like thermal compound, to the bottom of that package, which is either acting as a temperature sensor or is helping the heater. I'm pretty sure it's just a temperature sensor. And some capacitors for filtering stuff, and this is pretty weak output as well, so it's only like half a volt peak to peak into 1 kilo ohms. So initially it was mounted on a board with some buffers, and yeah, very, very nice part actually. And I'm going to, if I don't ruin it for you guys, I'm gonna try and fix it, but I don't like my chances of that happening. Anyway, I think I can find another couple of these. They're very old, as you saw in that sponge. The age of these things is remarkable. Some of them, most of these things are far, far older than I am, so. And you can see the transistor, I think. So the transistor is screwed on with that nut over there, and this thing basically disables the transistor heater. So I'm pretty sure that that's the reason why this thing is failed. It might be just the transistor is shorted. And if we expose this thing, you can see a beautiful physics package, or whatever you want to call this. And let's see if we can take it apart further. And I'm pretty sure that I'm meant to take out these two tiny nuts there. And for that I shall use these things. Okay, so one is down. And this is copper, by the way, machined copper. You can see that I'm leaving fingerprints all over it. So that's just a thermal compound securing the thing. And apparently it was screwed in into that block of phenolic resin or whatever. Let's bend this thing out of the way and see if we can take this apart further. It might be soldered in place, soldered. Oh, I can see, so there's a couple of, actually one solder bridge that goes from the top of that PCB to the other side, and it's holding the sandwich together. Whoops, apologies, I didn't break anything, I promise. So, I still didn't break anything. That's remarkable. So where was that bridge? I think it's around here. Nope. Maybe this one? Yep. Okay, so this has got to be just the quartz crystal itself. Oh, come on, why not? Let's take it off. For you guys. Anything for you guys. That is, if I manage to take this off. Oh, and I didn't answer one of the most important questions, which is why would you galvanize a quartz crystal? Well, mechanical properties change with temperature, so what better way of making sure that something doesn't change with temperature other than keeping it at a very stable temperature? So we're going for broke here. So I'm just going to look for a replacement for this, although I actually have no need for a very high precision. That was dumb. I don't have any need for a high precision or high stability, basically, crystal oscillator, but yeah, I have several now. Well, several minus one. If I still had the lathe, I could have turned the lip on the lathe and extract it this way. So this should be, I think, a very hermetically sealed crystal by the looks of it. It's got the same seal as a Coke can would have. It's a double lip, and luckily it's copper and it's very easy to cut. And Let's see if we can extract this. Not sure if it's gonna be very pretty. Like, I'm kind of butchering it. So, apologies if you love these things and regret seeing me do this, but it must be done. I'm making it more educationally friendly, as I like to say. Oh, there's multiple sandwiched hermetic packages, one inside the other. Wow. Ouch. Can you tell I'm losing my patience? Yeah. So, the beautiful quartz crystal itself. Here we have it. Very thick. We shall extricate it further. Oops. And let's bask in its glory for a while. Beautiful. Okay, so I made a mess. It's time to make even more of a mess. Just a second, I want to show you something. So, remember when I told you about IPRS Bonassa? So, the electronics semiconductor and electronics components manufacturer in Bucharest. So this is the technology that they had up to about when communism fell, so up to about the 90s. This is a 2-inch wafer, and this is actually IPRS Bonassa manufactured wafer. Very cute, but very small. Okay, let's take a look inside the next one. So for the sake of speed, I took it apart previously a bit. There's some very nice felt in this thing. I don't know what's wrong with the color balance. These are almost green to my eyes, but they're very blue to the camera. And of course, quartz crystal oscillator in here somewhere, and with another blankie. Aw, it has a blankie and heaters and everything. So yeah, let's see if we can completely destroy this thing too. It shouldn't be very hard. Oh, by the way, these capacitors that you can see here, this one in green here, these are very, very nice Soviet capacitors, and you might buy some Soviet equipment at some point, and you might observe that, hang on, this board is missing like 20-30 capacitors. Well, chances are that a board was missing capacitors. It was missing capacitors like these, because these contain precious metals, and everybody knows they contain precious metals. And yeah, that's why I've never seen boards that still had green capacitors on them. They're always scavenged. And I think that's a tunnel diode. I don't know why a tunnel diode would be needed, but it certainly looks like one. Actually, it might be a tunnel diode based oscillator, but that would make no sense for having a quartz crystal inside. Not sure. Might not be a tunnel diode, might be like a temperature sensor or something like that. And all the screws are absolutely horrendous. as in everything Soviet ever made. I've never seen a Soviet product with nice screws in it. It's just ridiculous. It's like that spell used to get rid of Dementors. Ridiculous. And that is a transistor stuck inside there. I think you can see it, the thing I'm desoldering right now. That's the heater, I think, for the package itself. So let me unplug the thing here. And let's see what's inside this bit. And it's wrapped with some twine so you can pull it out. It's just very funny because it implies that this thing was intended to be fixed at some point, which I absolutely find hilarious because it's obviously never been intended to be fixed. So, oh, there's one more screw. Of course there is. And we can see that inside we have a vacuum-packed quartz crystal. And let's see if we can carefully yank it out of here. Oh, it's going to be full of thermal compound. Ew. Ew, 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 ew. Ew, that is gross. Just a big dollop, like about as much as you need for a thread ripper. Ew. Oh god, that's so much thermal compound. I've never seen so much thermal compound in my life. But what's inside is totally worth it, because we keep finding better and better looking crystal oscillators. Oh Jesus, my hands are covered with this thing. So, oh, look at this, it's just glorious. This is like haute couture, artsy, beautiful. So, wait a second while I clean this off a bit. So we have a gold splattered, beautiful looking quartz crystal. It's so pure and clean, and it's individually serialized. So this is 5.00075, no, 1545 something megahertz. It's made in 1979. Just look at how pretty it is. Absolutely gorgeous. This is one for the collection, actually. It's so pretty. I've never seen any quartz crystal that looked like this. Beautiful. That was completely worth it. So, let me just wipe the Threadripper juice off of my hands. I'm not sure this thing is very good for you. It might be some of that Eoli thermal compound. Ew. Gross. I'm gonna have to clean everything off now. And let's take a look at the last one so we can immediately see it's doubly ovenized, and this is some sort of it's very stiff but very, very porous, like there's not much there. Some sort of plastic. And if I'm gonna try and extract this other side, but I don't have very high hopes because it seems to be very, very well stuck in there. So, sorry, forgot to clean the tip. And let's take this pair of flathead screwdrivers out. Screws, sorry. Apologies. I realized that despite all the things with my depression and stuff that I've talked about with you guys because you don't judge me, despite all that, this year for me has been absolutely excellent. Like, I've achieved a lot, and I hope all of you have had at least as good a year as I have, and I hope that next year will be even better for all of us. Ew, this is like earwax paper. You know, wax paper for cooking and stuff like that? Feels like earwax paper. Ew. Gross. I should have worn gloves. Jesus Christ, this is disgusting. Oh my god, this is... Get off of me, please. Okay, time for the IPA. Is this a sealed container? Yes, it is. I'm gonna give everything a bath in IPA. Jesus Christ, this is so... So before the IPA inevitably wipes everything off, let's see what's written on this thing. It's vanished right before our eyes. So this was a 1 megahertz crystal, I think, and it kind of looks the same as the other one we saw. And this is how I ruined my IPA. That was the last of it. And it's in a 7-pin tube socket, a tube sort of format. And this one is I think a lower-ish grade than the other because this one isn't gold plated, but it's still very pretty. So I'm just gonna wipe my fingers off with the acetone IPA. Jesus. So another one actually for the collection. So we have this beauty here, and it's poor brother from the country who didn't go to college. And what I find very interesting is I think that when I dismantled this thing for the first time, I actually ripped off these connections. So, whoops, apologies. I'm sorry, I did not mean to harm anything in this video, but turns out things made in the 80s weren't very, didn't lend themselves very well to being made very educationally friendly. But hey, I scratched the itch that makes me want to take everything apart and see what's inside, and I brought you guys along for the journey. Let me just pause the video for a second while I figure... Actually, I'm going to try and fast forward this section while I try and figure out how to extract this thing. So the thing covered in cloth here is a heater. So this is what temperature compensated, the temperature controlled the environment around that crystal there. So there can't be any more... Yeah, actually, there's got to be some electronics in here. So, if you ever come across one of these, just drill out these 4 things here. I don't know why that worked, but it did. Jesus. Looks thoroughly cooked in there. Oh. Right. Germanium. Why did drilling out the holes, why did drilling these out work? I have no idea. So this has got to be the oscillator assembly and the thing that kept the temperature sort of stable. I have no idea how they claim to have kept the temperature stable in that enclosure. I'm assuming that there must have been some sort of a temperature sensor somewhere in there. I have, wait, I surely have a socket for that screw, for that nut, sorry. Surely. I fixed it to the rescue. I got one of these sets. It's great. Should use it more. Oh, so there's a lot more in here than meets the eye. First time round. There's quite a number of connections. And I'm pretty sure, let's see if I take this out. Is it just gonna pop out? If I take this out, is it gonna pop out? I said, if I take this out, is it gonna pop out? Okay, this thing is starting to upset me slightly. What's holding it in? Oh, can't be. Jesus. I don't know why I keep trying to take this thing out. I think it's just ambition at this point. No, don't tell me. Is it gonna come out the other way? From the other side? Whoops. Pretend you didn't see that. Or didn't see that either. Or it is. This is some very steely wire. Very hard. I think it took the edge off my snips there, but mind you, these aren't the freshest pliers ever, but the snips actually. Oh, all that for a variable capacitor. And these are, oh look, so they did think, but not very well. They drilled a hole to be able to access the screws. If this thing was German, a German guy would have drilled a much smaller hole on either side for both of the screws. Or gal, German guy or gal. So no, Russia drill one big hole. No problem. Ivan fit screwdriver. This was pretty typical of Russian construction. Not that much thought went to stuff, but man, did they put them together with the strength of the Ural Mountains. Like, there's some screws on Soviet equipment that is just... the person tightening those screws must have been like a 6'8" tall person with steel muscles and lots of vodka in his blood system. Or actually, blood in his vodka system. Probably had a pet bear named Alyosha or something. I don't know what a bear name is. Anyway, I'm beating a dead horse. These are, I think these are heaters, because they kind of look like they're thermally coupled to the jacket of the thing. Oh no, they're covered in the same thing. Ew, no, I'm not gonna touch it. So, by far the dirtiest. Let me just separate this beauty from its chains. And I'm gonna give it a bath in isopropyl alcohol and clean it nice and proper. And yeah, this is very pretty. Right. Don't know if I had anything else for you guys. I do have loads more, but I don't think I have anything else at this moment in time. Anyway, the video is almost an hour long as well at this point, so I should give up while I'm still ahead. Like, did you see what I did? I mean, I'm not the first one who spilled acetone, or IPA actually, on himself. Remember to brush your teeth every day in the morning and in the afternoon. Oh, you're still watching? Nah. I'm joking. Thanks for watching, guys. Sorry about the style, but I had a lot of stuff to show and not a lot of time to show it, so thanks for watching. Have a great evening, and see you next time. Bye.